Hello, welcome everybody to our presentation, Industrial AR Clouds on Open Standard. And my name is Johannes Beer. I'm with Threedy GmbH. I'm a co-founder and CBO and was before with Fraunhofer for 15 years.
My name is Jens Resch. I'm the responsible manager for the PDM backbone at Mercedes-Benz. And I will start for you this presentation with the use cases we had and we still have in our PDM environment. So with our PDM backbone, we have a system which has a lot of data and also a good client with all the capabilities that we need to create structures, to have release workflows, to have the authoring system with us to get CAD data. And also the visualization inside this client happens based on JT. But we faced 4 to 5 years back more and more use cases where our customers said they did not just want to see some parts or parts of the vehicle. They had the need to compare complete cars, to compare, for example, the manufacturing concepts or different configurations of the car to see the difference in the parts. And this was not possible anymore with our traditional client. So this was the point where we decided we need a new visualization technology, which enables especially this visualization of huge amount of data. After a short research, we came up with this instant 3D hub, and we started a collaboration together with Johannes and Fraunhofer at that time. So here we found a web technology-based client which was able to have good rendering on the back end, but also to provide some of these features like measuring, cutting, clipping inside the browser. With this we started as a first prototype and soon came up with a whole platform which we established beside our traditional PDM backbone. So the PDM backbone provides the data, but with this visualization platform, we provided them to our customers. So when we started then by providing this data, we also saw that there was a big need for also having multiple devices, like for example, tablets or mobile phones, because we had use cases like being on the shop floor or being in the pre-production or even sitting inside the car, and the people needed the CAD data or the car data. And with these devices we also faced a lot of times the discussion about security, and here we had the advantage that the data never leaves our PDM backbone because we had just a zero footprint architecture. And so finally we provided the visualization even as a service to our customers. So the data never leaves our system. There was no need to copy data. So like everybody in the PDM domain, you know maybe these use cases also in your company, that all the customers who have different applications, they download data, they transfer it, and they use it in their application. And you have everywhere the discussion about security, access rights, and also this whole data transfer. And this is in our scenario not necessary anymore. In the next level, we started to extend this client because the customers had been aware that they could easily write their own applications on top of our client, or they just take the visualization and program new apps on their own. So for example, what you see here on the picture in the top left side, that we combined augmented reality use cases together with a drill down into the PMIs. All this was established quite fast and easily by our customers, with no further need for an adaptation. And nowadays we are now in the next step. So we have now a visualization platform which has its data and provides this visualization, but we have now also the need for our suppliers, because here they want to have the data to provide it for any kind of, for example, manufacturing facilities, but we do not want to give this data out of our hand. So therefore we now start to provide offline hubs. That means specific instances with our data, and we just provide the access to the supplier without copying the data. So the data never leaves our company. And with this, I want now to hand over to Johannes, and he will show you now the platform which is the basis for all of this.
So we as Threedy provides the Instant 3D Hub platform, which is our web-scale visual computing for industrial 3D apps and services. And we observed a very strong trend with Daimler and other customers over the last years that in general 3D apps and services are a key enabling technology for their digital transformation. So to accelerate these with these interactive apps. And in general, they face multiple challenges. And one is, for example, to go from single user in single location to multi-location and user incorporating collaboration platforms in a specific application. Then the second one is really going from single application and local data in form of a file like a CAD workstation that works with a CAD program on a single file to really applications that incorporate multiple resources from different sources in a single online application. And third, going from simple single device application where you have a very capable CAD workstation and with a wired company network to devices, bring your own device, bring any device networks where you have mobile devices like this HoloLens that's just wired, and you have to deal with this different bandwidth requirements and bandwidth properties. So this is really tricky. And another important point is that people move from manual data preparation, so from extra tasks that put data into specific formats or properties into fully automated and live connections. So data is not something that comes out of a process, but it's a continual asset that lives in the IT infrastructure and can be accessed through services like the Instance Threedy Hub. And last but not least, really, what's for us really important, that people move from simple viewing applications, so classical systems that they did with JT before, that they just looked at the data, to fully integrated application where they connect the 3D data with multiple apps to different backend data. So, and this all together is something that we really try to achieve with a single vision and a single platform. And what a good estimation for this is if you think about Google Maps for 3D data. So the idea is that we can deal with any data, any size, any device instantly. And in this case, it's about 2,500 JT data sets that have in total about 100 million triangles. And here, this is visualized in real time on a standard PC. And you can see that this goes down to every single PWeb element, so it's not reduced data, it's not just a lot that gives us fewer data on the client, but we can really do all the measurement and all the operation on every level of the data. And this gives us and the application developer a lot of freedom how to combine this. And this is built with this unique platform that actually combines the scalable 3D apps with the 3D spaces in the middle. And what's really unique is that it's the first platform where you can really minimize the integration costs with this connection to standards while really maximizing the user experience in the client. So it's really important for us that it always feels good, it feels right, like with Google Maps, it's always responsive, always friendly. So, and this is achieved because we connect on the left-hand side to the standards. We use linked data standards and web standards to connect business data, but 3D data with simple REST interfaces that use elements for negotiation and formats and connect those directly to the 3D spaces, which are then distributed with the 3D streaming to the clients, where we control really how the data is refined and really viewed. And there we can, for example, again on the HoloLens, really provide the full data set, so 100 million triangles on these mobile devices, which is really way over what other people really do on these devices, on the class of devices. And the interesting part is now that with this platform, people like Daimler not just have a single application that they move through their infrastructure, but multiple applications where they combine different aspects. So they start usually just with viewing, that they have zero code, plug and play solution where they use the applications that we provide with the system to connect their data backend and then have the instant viewing on the data. Then they move on to low code space plugins where they connect metadata with some external business data to view, for example, ERP data directly on pop-ups in the views, and then to fully custom apps and in custom runtimes where, for example, with this game engine integration, we can really build totally external application. And on the other hand, people move from simple 3D files into the 3D data and into the 3D domain, so more on the 3D operation complexity to 3D shapes and connecting really the 3D data with pixels with this visual compute as a service infrastructure. So every pixel really knows how the related 3D data is bound and was connected. And if we combine both, we get really unique application like this augmented reality application where very specific interfaces are used for the application connection, but on the other hand, just PMIs from the JT standard are used directly to overlay these in the system. And this combination gives us really this 3D clouds on 3D spaces, which gives us a lot of freedom to combine really this high requirements. So this really need to combine model-based tracking with this client-based tracking with the real-time data, and this in a real-time environment. And this needs usually a lot of tweaking, a lot of extra effort, and the infrastructure that we use really automated this completely. So we use this fully automated platform to actually put this standard on the device in 3 steps. So on the cloud, we really use the session management and services that do visual computing and 3D streaming. In the middle edge component, we actually use the model-based tracking to match the 3D models with the video stream that comes from the client. And in the client itself, we only do the 3D streaming, decoding, rendering, and the sensor fusion, where we actually combine the information from the model tracker and the SLAM to doing the overlays. And this gives people a lot of freedoms. They can incorporate different data sets, different standards into a single application. So, and after these years, we can really say this is a validated infrastructure. So the 3D spaces is something that gives customers, Daimler, really values and benefits. So they can use, for example, really any device. So it's our part of the system really to provide these connectors, build any app, have APIs that allow them to build really custom apps that run anywhere, increase efficiency with the 3D streaming and 3D caches to do this any data everywhere, and of course collaborated scenarios where you collaborate on really spaces and not just data. This gives us the foundation for the journey that now comes. So where we are right now, and there I give back to Jens.
So just to summarize and to show you what journey we have behind us. So we started 4 years back with a simple proof of concept, with the need for finding a visualization solution which is capable to show a huge amount of data in one scene. So this is where we started and where we had the first MVP. But short after this time, we saw that this is the basis for a platform we wanted to build, and we started to set it up to enable new user groups using PDM data without copying data. So at that point in time, we created an own web client beside our classic client. That means we now move our users away from this authoring tool more to this using the data tool, and also supporting mobile use cases. So right after establishing this platform, we saw that we had a growing user base, which then automatically led to the need that we had to increase our infrastructure. And at that point in time, it was still the classical infrastructure on our data centers. And having this in place, we then enabled more and more use cases. Some developed by ourselves, some developed by our customers, Mercedes-Benz internally. They could do it by writing their own applications, or they could do it by configuring our application. And now we are in the final step that we said, okay, the next step for growing is that we not just take the next hardware in our data center, but we will move this whole project, this whole application into the cloud, because there for us is the next step that we see we need ad hoc scaling. We need provisioning of individual hubs, and we need a lot of data which has to be provisioned in a short time to support these supplier use cases. And to do this fast and easy, we want to go to the hyperscalers like Amazon or like Microsoft. For example, buying vGPUs is very costly. Buying GPUs is very costly, but just provisioning these things and then maybe scale them down if they are not needed anymore, this is a quite interesting use case for us. So with this, I want to conclude our presentation regarding the open standards, where I have to say in our use cases, we saw that the standards helped a lot to make us faster in the product development and also to enable our customer to create their own apps on top of what we already did. So the architecture itself helped us in many cases to have an easy integration of features like augmented reality in various areas in the company. So this, for our understanding, is only possible because we have a quite stable service architecture below. So the platform we get with the Instant 3D Hub is stable, and it reduces for us the need for refactoring or rebuilding parts of the application just because the users changed, the location changed, or the use cases changed. And as said before, the next step for us is now to go into the public cloud and to provide or to use all the features available there for fast provisioning and easy scaling.
And that's also where we focus on right now. So we started with specific GPU servers a couple of years ago and moved now more to cloud environments. And also for our product and general systems, this is an important step. So we built something that we call hub mesh that allows us to combine different hub components and then dynamically configure GPU and non-GPU environments together with real and virtual environments in full hypercloud systems. So moving from a standard service environment, so the microservice infrastructure that was a service environment, to a more Docker environment is also for us an important step, and we see the future and are really looking forward to move even to more interesting places with Daimler in the future. So this concludes our talk. If you have any question, please, we cannot answer them right now, but use the app and we try to answer all of them until in the conference. However it works, we'll find out. Okay, thanks for listening and watching.